So in this video, we'll explain and go over section 6.1, problems 45 through 49, okay? At this part of the video, I'm going to explain 45. We're going to find the domain of these functions, and I'm going to write it in, I think it's like interval notation. I forgot what it's called, but it's interval notation, like a certain fancy interval notation thing that people use because they prefer it, I guess. And this will start, well, to show us, to find the domain, we take these two numbers and we say that because this is a natural logarithm, in, that means that this set of numbers is greater than 0. So we're going to say 4x minus 20 is greater than 0, okay? Then we move on to the next step. So we subtract, or we add 20 to both sides. So we would have positive 20 over here and 4x over here, okay? Then we divide the whole thing by 4, so we get x by itself. And that is where we get x is greater than 5, okay? And then we write this in notation. Domain of x is equal to set of real, where x is a set of real numbers, 5 and infinity. There we go. And there we go. That is our first problem solved. Here's the next one. It's a little trickier. It is a quadratic equation, which is actually kind of fun. I'll explain why. Let's start by saying it is greater than 0. So greater than 0, okay? Then we solve for this. So 6 plus 3 equals 9, and 6 times 3 equals 18, okay? So we're going to get x plus 6 and x plus 3. And then that's greater than 0, okay? And as you can see, if you multiply these by each other, you get this. It's factoring we're doing. And then we distribute these. So this becomes, so I'll start writing out d of x is equal to a set of real numbers, okay? Where, okay, this interval goes on for negative infinity, okay? All right, it's going this way. So when it's going negative infinity, this interval goes that way, right? Negative. Then it starts at, it's the interval, negative infinity to negative 6, okay? Then, see, this is what I got over here. This is, when we plot this, we plot it as negative, don't remember off the top of my mind, but that's how quadratics are. I've done this quite a few times. It's kind of hard for me to explain right now because I'm focused on doing other things. Here we go. Yep, and then this is where we have negative 3. Negative 3 is where an interval picks up and then continues on to positive infinity, okay? And that is our interval. There we go. The next one is 47. Okay, so this is a bit tricky. I'm gonna pull up a chair. All right. This here is solved on its own
and this here is solved on its own, and then they interact with each other. So I'll show you. So you say x plus 2 is greater than 0. But when we have this, we have x squared minus 1 is not equal to 0, because the denominator can't equal 0. Because you can't divide anything by 0, or you can't divide anything by 0. That just doesn't work. So we know that it is not equal to 0. Okay? From this here, we get, we just move the negative 2 over. We just subtract 2 from both sides. We say x is greater than negative 2. That's really easy. This is pretty simple. But this over here, sorry about the wobbly camera, this over here, we have to go through it a little more. Because negative 1, like we have to split up this x. So we can factor it by saying, let's see, x plus 1 and x minus 1 equals this, because x times x is x squared, x times 1 is x, or x times negative 1 is negative x, and then x times, or the positive 1 times x is positive x, and positive and the negative x will cancel each other out, and then you get positive 1 and negative 1, and you multiply them by each other, you get negative 1. Okay? Okay? Then, let me think. Okay, so next, you put this in. So you put this in as part of the interval. It's the first part of the interval. So I'll start writing up the notation. Equals the set of real numbers where negative 2, where x is the set of real numbers, the set starts negative 2, negative 1, okay? And then, see, we just use a negative 1. It's actually this negative 1. This turns to negative 1. Then this goes to positive 1. But we don't place another negative 2 here. So instead, we put the 1 here, the negative, the infinity happens after. There we go, see, infinity. 1 to infinity, yay! And then there we go. And that is our next notation, okay? I'm gonna have to turn the page for this next one because I ran out of space. See, I got them both written down. How convenient. Okay. This next one has the same problem from before, and I'll have to show you. It's the same quadratic. X squared plus 9x plus 18. The one was 6 and 3, remember? This one right here. See? 1 was 6 and 3. Okay? So we can easily factor this out. It is also a rational equation, so we will have to put that together. So we'll say this one, we'll just do what we did before with this one, where it's greater than 0, and then we just split it into x plus 6 and x plus 3, like last time. This one, however, it's the same as the other one. However, it is not equal to 0, rather than greater than 0. So we have this one, see? The 4x minus 20, okay? And then 4x minus 20, right here, we'll say, we solve this the same as we did last time. We'll say 4x is not equal to, and then we add 20 to both sides, so we say 20. Then we divide the whole thing by 4, because we want x by itself. So then we get x is not equal to 5, okay? All right, got that? So that means our interval happens, imagine a drum roll, here we go. And a set of x, real numbers, there we go. And
we get these turn to negative, so we get these actually happen within one interval, like one of these, one of the intervals. So here's the interval right here. Then we have a second interval. Our second interval includes this one. This one is entirely positive. See, they're separate. Okay, now the cool thing to show about this one, sorry, I didn't make this negative. The cool thing, well, it looks like Pinocchio or something, long nose or something. Anyway, there we go. Okay, so we have negative 3, and it's n squared repeating. Look at that. This is the same, and this is not the same, but we have the same numbers. So, okay. We just put them in one, like this. So we're going to finish the domain by doing that. Sorry for curving upward, that's just how my hand goes. Everything kind of slides up. Anyway, now to 49, the last problem of the day. Yay. So, yeah, it's a natural logarithm, and this one is super easy. So we're going to say 7 minus x, okay? 7 minus x is greater than 0. And we're also going to say x minus 4 is greater than 0. Then with these two together, because they add up together, we're going to solve for both. I'll start with this one, since it is the first coordinate. We'll add 4 to both sides, so we'll get x is greater than 4. And add 4 to this, it cancels out, add 4 to 0. See? Alright, this here is super easy. You subtract, or you add x to both sides. I'm going to say we add x to both sides because I don't like negative x. It's just too negative. So we're just going to, if we add x to negative x, they cancel each other out. If you add x to 0, you get x. And then therefore, we get 7 is greater than x. And then if you look, we end up getting x is greater than or is less than 7, but is greater than 4. So there we have our interval between 7 and 4. And right here, we're going to start, actually, the way this is written is set of real numbers where 4, it's from 4 to 7. And we're done.